This lecture deals with graphical presentation. In it, we'll be discussing several different kinds of graphs, including pie charts, bar graphs, histograms, frequency polygons, time series charts, and statistical maps. The lecture also talks about common graphical distortions and advantages and disadvantages of using graphs. So, what is a graph? Well, a graph is a device used to create a visual impression, and it can easily summarize hundreds or thousands of pieces of information in numbers. Graphs are easier to look at compared to tables, but they lack their numerical precision. Starting with a simple kind of graph, something called a pie chart. This graphical device is commonly used with nominal or ordinal variables. In it, the variable categories make up the slices of a pie, and the segments add up to 100%, or the total number of cases used in the analysis. Here's an example of a pie chart. Notice that it contains all the essential features, just like a table. For example, it has a descriptive title and number. Here we see that we have a pie chart of the highest degree earned. It also includes a total number of cases. In this example, we're using a sample of 1,974 cases. And it also includes a data source. Here we see that the data are coming from the General Social Survey, or GSS, 2012. So what kind of patterns can we see in this pie chart? First of all, we can see that the majority of cases, almost half, have only a high school education. The next most common category is bachelor's degree, which makes up just under 18% of the distribution. Just under 15% of the distribution has less than a high school education, while about 10% have a graduate degree, and the lowest category, junior college, makes up just over 7% of the distribution. One way to make a graph a little bit more readable is to do something like this. Here I've exploded the categories of the pie charts, making some of the patterns a little bit more easy to see. We can see that here bachelor and graduate are set off a little bit. That's just to distinguish them somewhat so that the pattern is a little bit easier to see. Incidentally, it doesn't matter if you use a frequency or percent distribution in this graph, and in general in most graphs, as the basic picture is basically the same. Another type of graph that's used with nominal and ordinal variables is something called a bar graph. In a bar graph, the categories are displayed as rectangular bars that are proportional to the frequency or the percentage of each of the categories. Typically, the horizontal axis arrays the variables of the categories, and the vertical axis contains either the frequency or the percent, whichever one is chosen. So here's an example of a bar graph of the variable race. Notice that the bars are set apart from one another. That's to indicate that race is a discrete variable, and its categories aren't measured on a continuum. What kind of patterns do we see from this pie chart? Well, the most obvious pattern is that most of the sample is white. So we can see here that 1,477 cases are white, whereas the other categories are a little bit less common. So here, black and other, the other racial categories, make up 301 and 196 cases, respectively. Now, the preceding information could have been represented either as a bar graph or a pie chart. However, there are some cases where a bar graph is better to use than a pie chart, especially when you're using comparisons over multiple groups. The next graph shows a bar graph of race by sex. Notice that this information couldn't as easily be shown in a pie chart. In fact, you'd have to use two pie charts. Certain information has been added to this graph to make the comparison across different groups more obvious. For example, the legend indicates that the variable is being shown for two different categories, males in the black and females in the white. Incidentally, it's good to use contrasting colors when you're using a bar graph like this one. That way the colors are in clear contrast to one another, and the patterns stick out more visibly. Also, I've used percentages here rather than frequencies because I'm making group comparisons. In such a case, it actually matters whether you use percentages or frequencies, especially if the number of males and the number of females is different. And so the better option when you're making group comparisons is to use percentages, because they standardize the number of cases, as if both come from 100 cases. So what's the actual pattern here? Well, in general, we can see that there are more men than women for several of the racial groups, especially white and other. But the pattern doesn't hold for blacks. Here we see that there are more black women than black men. Another thing to consider is that when we're making a bar graph, we can put the bars either on the horizontal or the vertical axis. The choice is really arbitrary. In the next slide, I show a horizontal bar graph. although one could make a similar graph with vertical bars and create the same basic impression. So in this graph, we see class differences by sex. And so men are coded as in black and women are coded in white. And we can see that for both, the pattern's pretty similar. The majority of cases are in the middle, either working or middle class. And the differences across men and women are pretty small and insignificant. Another kind of graph is something called a histogram. And this is used for interval ratio variables. It's very much like a bar graph, except the bars are contiguous, and their width is proportional to the interval size of each of the categories. So here's an example of a histogram for education. Notice that it looks much like a bar graph. The only difference is the bars are actually touching, that is, they're contiguous. That's to indicate that the horizontal axis measures the values of the variable education on a continuum. What's the actual pattern here? Well, for one thing, we can see that there's a wide span of the data. About 20 years separates the person with the most education from the person with the least education. We can also get an overall impression of the distribution. It looks like there are more people on the high end of the education scale than on the low end. That is, most of the cases are in the right tail of the distribution, not the left tail of the distribution. We can also see that there's some evidence of peaking in the data. And so we see peaks basically at terminal degrees. For example, 12 years of education, 14 years of education, 16 years of education. These are probably terminal degrees like a high school education, an associate's degree, a college degree, and so on. Histograms can actually be used to make comparisons and depict more complex trends. As an example of that, consider something like the following. The next slide will show an age-sex pyramid, what's also known as a population pyramid. That's something that's frequently used in demography to show the age and sex structure of a population at a given point in time. Basically, it's two histograms that are put together with the categories of the variable arrayed along the vertical axis and age on the other axis. And so you can see here, this is a age and sex pyramid, or a population pyramid, showing the U.S. population in the year 2000. And we can see that males are on the left, females are on the right. We can see that there's a bit of a bulge around the 35 to 40 to 44 age ranges. Those are probably members of the baby boom cohort who were born between 1946 and 1964. They make up a large portion of the population, and it's very obvious from this population pyramid that they're a larger portion of the population. Another way to show categories of an interval ratio variable is to use something called a frequency polygon, or what's better known as a line graph. A line graph basically utilizes points representing the midpoint of each category, and those points are joined by straight lines. So here's an example of a frequency polygon or line graph of father's education. Notice that we can see several peaks at, again, terminal degrees like 12 or like 16, which correspond probably to a high school degree or to a college degree, respectively. Now, I could have shown this using a histogram as well, and it really doesn't matter whether I use a histogram or a frequency polygon in this case. The basic pattern will be the same. It also doesn't matter if I use frequencies or percentages, because I'm not graphing more than one group. However, there are times when using a frequency polygon has its advantages over using a histogram. For example, if I was to make group comparisons, I would probably have overlapping histograms, and so it would be difficult to see the patterns. In such a case, it's better to show frequency polygons. And so as an example of that, here's a graph showing father's education for different racial groups, whites, blacks, and other. And notice that whites are indicated by the circle, the triangle is used to represent blacks, and then the square is used to represent other racial groups. So we can see several different patterns. For one thing, we see that there's differences at some of the peaks. We see that whites have fathers who are more educated than blacks and other. And that's true for 12 years of education, and looks to be true for 16 years of education, although the difference between black and other is less pronounced at 16 years. We can also use line graphs to show time series. And when we do that, we create something called a time series chart. So a time series chart basically just shows the change in a variable over time. Time is represented on the horizontal axis, and the vertical axis represents some variable. Time series charts are also good for group comparisons. So take a look at this. This shows the average adult education from 1972 to 2012. Notice that on the horizontal axis we have year, and then on the vertical axis we have the average education of people in years. And the basic trend is that education, on average, has been going up over the years. What if we wanted to represent distinct groups? This graph shows the average adult education in the same year, 1972 to 2012, separately for males and females. So what's the trend here? Well, we can see that men's education is consistently higher over time than women's education, although the difference seems to narrow towards the end of the time series. Another statistical device that we can use is something called a statistical map. And this is used to graph geographical distributions of variables. Variables are basically mapped by assigning different shades of color to each code indicating each category of the variable. And the colors become attributes of particular geographic units on the map. So here's a map showing the 1999 population of the mainland United States. Notice that there's 4 different categories, each indicating a different range of population size. So the light gray basically shows the smallest population, and the darkest gray shows the largest populations. And then each of these different populations is assigned to a different U.S. county as it appeared in the year 1999. So what's the pattern here? Well, we can see that the population is higher on the coasts. In general, counties on the coast tend to be more densely populated than those counties in the interior of the country. In fact, most of the interior of the country seems to be comparatively less populated. Okay, now that we've talked about several different kinds of graphs, let's talk about graph distortions. So, although graphs can quickly inform us of some kind of a trend or pattern, they can also quickly deceive us. And graphs are particularly vulnerable to distortions because of the way that they're created to create a general impression, rather than their focus on having a detailed analysis. So, one of the most common forms of graph distortion is to alter the distance of one of the axes relative to the other. So in the next slide, we'll see 2 graphs showing the identical data. This will show the average adult education that we saw in an earlier slide between 1972 and 2006. Okay, so notice that in panel A, we have a condensed horizontal axis. And when you compare that to panel B, you can see that the time trend appears to be more steep. That is, the time trend in panel A looks like the education level is increasing much more quickly than in panel B. But in fact, these are the same data. The only difference is that panel A has been truncated compared to panel B, making it appear steeper. So be aware of this kind of very common graph distortion. It can create a very distorted view of what's actually going on in reality. Another way to distort a graph is to use pictures rather than to use numbers to represent quantitative data. So in the following picture, we're using figures rather than numbers to represent HIV rates around the world. So notice that the HIV infections in Africa totaled over 6.5 million. And that's about over 6 times more than what we find in either South or North America. The problem, however, is that the African figure is about 20 times larger than some of the other figures, which makes it look like the incidence of AIDS in Africa, or HIV, is much higher than it is in other parts of the world. So ideally, we should probably use a statistical map rather than this sort of figure to represent the trends around the globe on this map. What about some of the advantages and disadvantages of using graphs? Well, there are several disadvantages. For one thing, graphs lose numerical detail. So if there's some kind of other pattern that you wanted your audience to see, they wouldn't see it because you've hidden it by creating a graph. So you lose the ability to see additional relationships that aren't being highlighted in the graph. The other problem is that graphs can be time-consuming. People spend a lot of time formatting the graphs, putting in a color scheme or what have you, and that takes a lot of time. So graphs are potentially time-consuming. However, graphs have several advantages that make them worthwhile. They give you the ability to direct the reader's attention to a certain aspect of the evidence. And it allows you to kind of reach an audience that's intimidated by numbers. Some people simply don't like to look at tables, and so they can see the patterns much more easily using a graph. And graphs also give us the ability to see the bigger picture. and so they can be useful in some circumstances.